Greetings, chemistry students. Today we're going to look a little bit at the structure of ionic and covalent compounds. So first, we're going to talk about ionic compounds. So in ionic compounds, ions with opposite charges are strongly attracted to each other. So for instance, this potassium ion and this chloride ion, since the potassium has lost an electron and is positively charged, the chloride has gained an electron and is negatively charged, they are attracted to each other like magnets. Now, when you create a larger scale ionic compound, they are placed in this regular repeating arrangement that we call a crystal lattice. Let me kind of show you how this works. So if we take one potassium and one chloride, they're attracted to each other. Then if we have another potassium, another chloride, they're also attracted to each other. But if you bring them close to each other, this potassium is also attracted to that chlorine, and this potassium is attracted to that chlorine. And then you can have another one, and then you could have another potassium chloride, and you get this regular repeating pattern, like so. So for instance, this potassium right here is attracted to the chlorine above, below, to the left, and to the right of it. And also, since this is a three-dimensional structure, there would be a chlorine in front of it and a chlorine behind it. And this chlorine is attracted to those two potassiums and those two potassiums, plus a potassium in front of it and a potassium behind it. And so that gives you this regular repeating arrangement and the structure. And the simplest ratio of ions present is called a formula unit. So there's the term molecule that we use for covalent compounds. The technical term for an individual ratio of the ionic compound is called a formula unit. So a formula unit of potassium chloride is just one potassium and one chloride. For calcium chloride, since calcium has the +2 charge, a formula unit of calcium chloride would be one calcium and two chlorines. Now, this leads to some unique properties of ionic compounds because of how they're arranged. So, ionic compounds have high melting and boiling points because it's going to take a lot of energy to separate the potassium from the chlorine because they're pretty strongly attracted to each other. They are brittle, meaning that they will break easily. Now, the reason for that is if you apply some type of pressure to this and you cause it to shift just the slightest bit, like if it just shifts one atom over, now you've lined up chlorines with chlorines and potassiums with potassiums. They're going to repel each other and it's going to break. Or if you slide it, apply pressure horizontally, it's going to, as soon as it shifts just one atom, it's going to break because you now have like charges lined up and they repel each other. So that makes this brittle. In earth science, you may have learned about what's called cleavage planes in mineral structure, where they break along these specific lines. And a little experiment you can do at home is go get a salt shaker and sprinkle out a little bit of salt and look at it. And you'll notice that the sodium chloride, it looks like perfect little tiny cubes in many cases because it breaks in these perfect little lines. Ionic compounds also conduct electricity when you melt them or when you dissolve them in water. So that's how you can identify ionic compounds. For those of you in cohort C, you'll do a little experiment with this when we come back on Monday. Covalent compounds have lower melting points than ionic compounds. They can be a gas or a liquid at room temperature, and they are poor conductors of heat and electricity. So they do not conduct heat and electricity really well. Today we're going to talk about the third category of compounds that we're going to study in this unit, which is metallic compounds. So metallic compounds are obviously made of metals, the things on the left side of the periodic table. And they are formed when metal atoms share their electrons collectively. So the metals, which have low ionization energies, they can easily lose electrons. When metals bond, they basically just release their electrons to be shared equally with all the metal atoms as they need them. And this is what we call a sea or an ocean of electrons. So you have the positively charged uh, atom with its valence electrons, the negative electron charges freely moving amongst them. And that's what gives metals their unique properties. Now, when it comes to these metallic compounds, we don't have any formal names or formulas for them. Uh, these things are called alloys, and they're just made in different ratios because you can mix them together in any combination you want to, really. But because of the structure of a metallic compound, that gives them the following properties. They conduct heat well, because if you heat up one part of a metal, those electrons can move around and bump into other electrons and kind of transfer that heat, which is essentially, as we'll learn later on, heat is essentially kinetic energy or energy of motion of the particles. They also conduct electricity really well because those electrons can freely move throughout the substance. Covalent compounds generally don't conduct electricity well at all because the electrons are locked up in those covalent bonds within the molecule. And ionic compounds can conduct electricity when you heat them up and melt them, because the positive and negative charges can move around, or they can conduct electricity when they're dissolved in water because the charges break up and can move around. But metallic substances can conduct electricity as a solid because the electrons can move through the solid because they're not attached to any one specific atom. Metallic substances are also ductile, meaning you can stretch them out into a wire. They're malleable. You can bend, mold, and shape them because the atoms are not bonded in a rigid structural arrangement. They don't have the crystal lattice of ionic compounds. They don't have this atom is bonded directly to that atom and not any other atoms like in a covalent compound. The the individual atoms are essentially attracted to this entire collection of electrons that are moving around, but it's not a rigid thing, so things have some flexibility. And the term we use to describe metallic compounds is alloys. Now, I kind of view metallic bonding like communism, if you will, because the electrons are just evenly shared amongst all the metal atoms as they need them.